recording again. Did you guys see the page I saved before everything crashed, or no? Okay. So I think where it crashed was when I was trying to load the file. So let me do that again. You won't be able to see it for a second until I share that window. So this is me sharing the other window. Okay. And so what you ought to be seeing is, why does it have an extra weird thingy after the link? Because I typed an extra weird thingy after the link. That's why. Is the two sentences at the top are on the same line. Remember, even though I wrote them on different lines of the HTML document, this is a p tag in between that starts a new paragraph with extra space. This is a BR tag that puts it down to the next line, and this is the link to the web page. So if I click it, it takes you to the OWU site. All right, so let me go back and show you the HTML file again, just so you can see what I did. All right. So I had two lines. The beginning part was to show you that having two lines of stuff on different lines of my HTML file meant that they were going to be the same line of the web browser unless I explicitly make a new paragraph or a line break. This is the link. So if you somebody said, I forget who it was now, said they're having trouble getting the links to work. This is what it should look like, I guess. So I don't know what you're doing to get it to not work, but here it is. I'm recording, right? Yes. So does that help? Any questions on what I just wrote or did? Okay. Any other problems with the web stuff? I've been telling people that this homework and lab is longer than last week's, just because you have to go through the lab and do all of the tags and transferring files over and read and write permissions and all that crap before you can get anything to work. The good news is I do think this is easier as far as complexity than the last week with the machine language stuff. So I think it's much more doable. I just think it's more time consuming. I think last week's homework was probably the hardest homework of the semester, just because it was such a weird way of thinking and getting all those arcane, bizarre numbers to do what they mean is challenging. So yeah, I mean it's all relative, right? Everybody has different opinions, but I certainly think so. I posted on Blackboard my answers to the first homework, the machine language homework. I'm still waiting on a couple of people to hand in the second homework late if they're gonna. But then after that, I will post my answers to the second homework, so you can see my thought processes and how that all works. So just as a rundown of the rest of the semester, so this week, next week, and the final week, and that's it, and then we're done. This week is about the web and the internet, and so the big homework is the web page. Next week is about writing more higher level programs in a language that's not machine language and getting something kind of closer. Did I get yours? I will check right now. Yes, I guess I forgot to say I got it, so hang on. Got it. Next week's is about writing programs in a language that's closer to what real people write programs in. The machine language was really to show you what computers can do in hardware. The next week's going to be about what computers can actually do. And the last week is going to be talking about algorithms, which is a little mathier, but at least it's not really programming. So that's the plan. I have to figure out how to get you guys the final at some point and things, but we're more than halfway done. stick with it. And always ask questions and bother me if you need help. A lot of you have been really good about sending me emails as you're going through the labs and are stuck. A lot of you have been really good about, and I've met with some of you like in the chat room at random times, not during class. If that helps you, I can do that. But I'm here more than just 2 hours a week to help you guys, I guess is what I'm trying to say. So use me. All right. So what I want to do now, is spend some time talking to you about the internet and how it works and all of that. And I don't know why I cannot get there it is. Okay. Open up my notebook to open. Okay. So as I start sharing my screen again. All right. So today's about the internet. It's about how the internet works. And what's going on. Okay. It'll help you, I hope, figure out a little bit about how the web stuff will work, but mainly I want to talk about how everything's connected and how those connections are done and how computers find each other and talk to each other and that sort of stuff. So I talked about this, I think, a little bit last time. The idea that most computers on the internet have two kinds of names. They have what are called human readable domain names. So the domain name will be something like Amazon.com or something like that. And then what's called IP address. That's a collection of numbers. So the idea is every computer connected to the internet has an IP address. The IP address is the numbers you use to connect to other computers. Okay, it's the numbers that computers use to talk to each other. The names are really just there for people to use and remember, because remembering numbers is harder for us to do than remembering something like Amazon.com or OU.edu. It's not. If you want to play along at home here, what I'm going to do is look up the IP address of a couple of computers, and I'm going to do that by opening up a terminal. So if you're on a Mac, this is your terminal program. If you're on a PC, this is your DOS prompt, your DOS shell. You can do start and then press command or CMD, and then you'll get this prompt here where you can type stuff. Okay. I don't know if you can see the bottom of this prompt. Can you see where I'm typing? Where I just typed that, the word ping? Okay. All right. So the word ping means basically send a little "Hey, are you alive?" message to someplace. And so if I ping, for example, OU.edu, what it's going to do is tell me, hey, I was able to talk to the owu.edu machine, and it responded back and told me that it was alive, and it'll keep on doing this until I tell it to stop. And what you want to see is the numbers there, the 104.239.175.178. That's the IP address of owu.edu. Okay, that's the numbers that connect to owu.edu. And that's why when I typed in ping the domain name, owu.edu, the ping program responded by telling me about an IP address, because computers think in terms of IP addresses and people tend to think in terms of domain names. So every computer has an IP address. I think I didn't have to install anything on here, at least, to get the ping program to work. So if you have a terminal, you can try this. You can ping Amazon.com, and they are it's timing out. That's pretty funny. That means it's not alive. I wonder if I have to go to. I mean that they're configured to not let me ping them because they don't want to have to deal with me. But at least they have a number, right? So the number is there. So they are 54.239.25.192. And of course, it doesn't matter what the numbers are. It matters that the numbers are different. If I ping, I don't know, ESPN.com, they are 199.181. Is that an 8181? I'm old. 132.250. The point is, every machine with a domain name that has a name you know about also has an IP address, and the IP addresses are how we send things across. Okay. Every machine connected to the internet, even yours, probably does not have a domain name because you have to register those and buy them, but you probably do have an IP address. If you type, I think it's ipconfig, in your text window, you get, oh man, ipconfig. Get? And I thought I knew. Well, I can do this. Localhost. That's so 127.0.0.1 is always the name for my local machine. You might have to go online to find your IP address. So there's a lot of places. Here, let me share my browser again. There's a lot of places online that let you can. So if you do a search for what is my IP address, you'll get a lot of. Actually, look at this. What is myipaddress.com? Look at that. And so it says that my IP address is 198.30. I lost the number. 46.190. So that happens to be my IP address on this computer in the Science Center of Ohio Wesleyan. Generally speaking, IP addresses work kind of like regular addresses in the sense that so my address was 198.30.46.190. Generally speaking, these numbers go from general to specific, in the sense that other machines that are located close by, or at least logically, sorry, I was typing, or it was logically connected to each other on the same network, tend to have similar IP addresses. So, for example, the server in the Math CS department that the majors do their big projects on is 198.30.42.10. And so the fact that 198.30 are the same and the fact that 46 and 42 are similar means, is because we're going inside the OWU domain, okay? The web server is actually called cc.owu.edu, and it's sitting at 192.68.223.1, and so not exactly the same. So what you're seeing here is that the numbers get slightly different as we get further away, and I betcha, I remember to stop typing. The web server, which is www.owu.edu, is 104.239.175.178. So when you go to the home page of the school, and their domain name is www.owu.edu, you can see from the IP addresses that they're in different places. The 198s tend to be things on campus. The 104 means it's being given to us from somebody far away, and those are the people that we paid to develop our webpage. I forget what the name of the company is called, but whoever the web development company is hosting our webpage, Bigtree. And so there, you can tell from the IP address that they're not local. Okay, so that's one way of using the IP addresses to figure out what is nearby and what is far away. Okay. Similarly, domain names tend to work the same way. www.owu.edu. The difference is it goes from specific to general. So the last thing in the domain name is the edu, and there's only so many .edu domains out there. You have to be a school, and not like a for profit kind of school, like a regular school. The OWU is more specific. It's one of the many EDUs, and then within that, www is the name of a specific machine within the OWU domain, which is within the EDU world. Okay, so there are relatively few what are called top-level domain names. These are the things like .edu, .com, .net, that kind of stuff. There's more, and every country has one. There's a .us, there's a .uk, and there's a .canada. But there's not millions. There's only, a few, maybe 100, maybe 400 or 500 of these top-level domain names. Each of those have lots of subdomains. So within .edu, we have owu.edu and denison.edu and harvard.edu and on and on and on and on and on. All of those are subdomains within the EDU top-level domain, and then each subdomain can have more specific stuff. Subdomains. So that's where our school's web pages live. This is an alias for it mostly. I think technically this is where your personal pages would live. The name of our machine that holds the files for our junior and senior majors, and on and on and on and on and on and on. The school supports some blog sites, and so I wonder if this is the case. Nope. You can type it. It actually kind of works. You can type in uc160.owu.edu, and it'll take you to. It'll redirect you to a page that talks about the UC160 class and all that kind of stuff. So the point is, there probably isn't a uc160.denison.edu, right? Because that's a specific subdomain of the other domain, and it works just like a regular address, right? 25 Johnson Street, Columbus, Ohio. This is general. This is specific, and you read the address from general to specific to figure out where you are. You read a domain name from general to specific to figure out what it is, right? When you look at a domain name, the first thing I do, at least, is look at the last part and see what kind of place it is. Is it a company? Is it a school? Is it a whatever? And then you get more and more specific as you go from right to left. You look at IP address, and you go general first and specific later. But either way. So that's a little bit about domain names and stuff like that. One thing I do want to bring up as kind of a reminder about how this stuff works, an IP address, oops, is 4 numbers separated by dots. Each number ranges from 0 to 255. Why do you think each number in an IP address ranges from 0 to 255? That kind of number should be a bell in your head. Any guesses? Yep. Remember, 1 byte can store 0, or it can store all ones, and all ones is 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which turns out to be 255. 1 byte, by the awesome formula of Doom, says 1 byte can hold 2 to the 8th, because I've got 8 bits, which is 256. Whoa, what did I just do? $256 combinations, right? And there are 256 combinations from 0 to 255. So 4 numbers can be held in 4 bytes, which is 32 bits. So the next question is, how many potential IP addresses are there? Total. Maybe scrolling up will give you a hint. So how do I know how many? Whoops. How do I know how many potential IP addresses there are total? Stop scrolling. I wonder why this scrolls so slowly and then doesn't let me. Okay. All right. So if I know that an IP address can be stored in 32 bits, or must be stored in 32 bits, how many different IP addresses can I represent in 32 bits? Let's ask it that way. Any guesses? No? Nothing? Okay. So this is another application of the awesome formula of doom. Remember the formula was 2 to the number of bits equals number of combinations those bits can represent, right? So that means is if I have 32 bits, 2 to the 32 combinations. And just doing it because I've done it so long, if you're trying to actually get me a number, I didn't want the actual number, I wanted like a 2 to the 32 kind of form. 2 to 32 combinations is about 4 billion. Combinations of IP addresses. So here's the third question. How does that make you feel? Do you feel like 4 billion IP addresses is enough if every single computer or phone or anything that's connected to the internet has to have an IP address? You think 4 billion is a good number, a good enough number, or too small? Why? So if you think it's too small, why do you think it's too small? Hello? Right. So one way to think about it is I'm going to look up right now the population of Earth. And Google tells me that the population of Earth is 7.4 billion people. So if everybody in the world had their own computer and had their own IP address, there wouldn't be enough, right? So this is kind of beyond the scope of the course, but they're developing a new thing called IP version 6, a new IP address format that has 128 bits, which is 2 to the 128 combinations. And 2 to the 128 is a number with about 38 zeros in it. Which is way more than a billion, or maybe way more than 7 billion. 7 billion has about 9 zeros. So people are working on ways to fix this, but it is an example of how things. So the IP address that we're using now was created in like the 80s, and so in the 80s we didn't really think about the fact that everybody in the world would want their own IP address and what would happen if we ran out. And so a lot of the internet is based on ideas that came out from the 80s that are kind of hacked together in a weird way as the internet kind of took off in unexpected ways in the 90s and 2000s. They can, but then we have to make sure that we are sure that the IP address is never being used anymore. Because of the whole domain thing, what ends up happening is every domain recycles their own personal IP addresses. So like my machine name of 198.30.46.190 will be reallocated by the school to another computer once my computer is not used. Actually, this is probably the IP address of my office. So whatever computer connects to my office is getting that IP address, and so that's how it's recycling. But you have to be on top of that, right? And even then, you have to worry about still not having enough just total things. So yeah, so it's a thing. This is one of those things people are working on. It's kind of you guys are too young to remember the Y2K problem, I guess. That was a similar issue where lots of people were storing dates with 2 digits, so 99 meant 1999. And then what would happen when the year 2000 came and 99 turns into 0, it gets treated as 1900. So what they had to do was go into all of these old programs and fix them, because people who wrote these programs in like the 70s didn't plan on what would happen when 2000 rolled around, because it was the freaking 70s, and who's going to worry about that? So this is every so often you got to, when you have an old computer system, and the internet's an old computer system, you have to go in and kind of figure out what's happening and how it all works. All right, so IP addresses, domain names. One thing that's worth showing you is so I don't know if you're going to be able to see me do this or not. I'm going to try to get a second web browser up and then show it to you. Right now it's the start page. And then I'm going to share that page. All right. So the school's web address is 104.2. So I'm going to write it down again. It's this one up here. 104.239.175.178. And I don't know if you can see me typing. I'm not going to talk. I'm going to talk and then type. I'm going to type into the bar the IP address and see what happens. Okay. Okay, so that is the IP address of the school's webpage. And if I type it in, because computers communicate with IP addresses, it knows to automatically take me to the right place, right? The IP address gets turned into the communication to the web page, and the web page comes up. Okay, so you can, if you want, go to web pages based on IP addresses instead of domain names, and it works just fine. Okay, what I can't do for a couple of reasons is go to my personal computer's IP address. So if I type in mine, which is 198. So that was the IP address of my computer. If I try to go there, I'm going to get an error saying I don't know how to do that. And the word you want to look at here is server, right? The only kinds of machines that can accept web page connections are web servers, machines that are specially configured to accept web commands and expect to give you HTML pages, and your browser expects to read an HTML page. So this is what I was trying to say last time about how every computer, there's a difference between the internet and the web. Many computers are on the internet but are not web pages. Okay. Another fun thing you can do. So let me go back to the OWU page. This was the IP address of the OWU page, 104.39.175.178. If I change the last number, let's say to 177, I don't know what this is going to do, but it's the IP address of a different machine. Maybe that machine exists, maybe that machine doesn't. Maybe that machine is a web server, maybe that machine's not. Let's find out. Wow, that was weird. I loaded this whole entire. Did I really do that? Wow. I wonder what 176 gets me. So 176, you can't see it, but it popped up a password request. 104, 239, 175, 175. I think what this is, I think I just hacked their system. This is awesome. These are all different numbers of different machines on the hosting site of the place that hosts our web page, and I'm getting there by typing different IP addresses. Let me type 1. I don't think that's going to work. So this one's just hanging. So the point is that if you change the last number of an IP address, you're getting different machines on the same domain. And so this domain is a site that does web page stuff for other places. And so I think I'm getting web page stuff for other places, or at least their internal configurations of things, which is fun. Look at me being a hacker. Okay, so that's IP addresses and domain names. The other thing to talk about with this is that you will often, you guys, I'm sure, have seen the phishing emails that come by every so often that ask you to send your password to places, or this is your bank and you have an account problem, go log into your bank, that sort of stuff. So let me see if I can find one on my email here. I'm going to log into my email. And then, do I not have a spam folder on here? Usually these things get sent straight to your spam folder. Oh well. I have a spam folder on my other email, so let me look at that for a second. Try to find something that's obviously. I have a Nigerian bank account. I have a bunch of people trying to sell me stuff. I have a bunch of. That's actually a legitimate email. That's another Nigerian bank account. That's Zimbabwe bank account. Job offer from Kmart. So here's a good example, actually. Well, not really. Here's what I'm trying to say. You'll often get emails from places that want you to change your address or something like that, or you have a password problem or something like that. And they'll say, I am the OWU administrator, and you need to log into this site and enter your password, or you're going to lose your email quota or something like that, right? And if you look closely at the address they're trying to send you to, it is not owu.edu. It is owu.edu.shadyplace.com. So that, or something like that, where there's an owu.edu in the link, But there's also other stuff after the link that is the actual place you're going to. So remember, if you are going to an address called that has the domain name owu.edu.shadyplace.com, and I am forgetting to share my note screen. The way this works is that this is the general, this is the specific. So what this actually is a machine named owu.edu that is owned by a provider, a subdomain. Let me say subdomain. That's the word I used before. Called shadyplace.com. Okay, so the idea is that they're trying to trick you into thinking it's a legit OWU email address, partially because the response it'll say in the message, "I'm from the OWU email address," partially because the address you click to has owu.edu in it. And if you don't know that the left side of a domain name is the specific part and the right side of the domain name is the general part, you might be tricked into thinking that this is a legitimate part of our OWU computer system, right? And so one of the big ways that you can use this knowledge of specific on the left and general on the right is to see whether web addresses are legitimate or not, okay? And what you want to look at is this part. That's the place you're actually going to, okay? And that's and that is not owned by OWU, at all. So that's how they get you, I guess. So that's the idea behind phishing and how all that works. Kind of sad I don't have any good things like this in my email box right now. I have a lot of. Ooh, I won 5.5 million in the Asian lottery. That's pretty good. So anyway, the last thing I want to do is talk a little bit about email. So I'm gonna show you once I open it up. I wonder if I can do this in here. I know how to do this in my email. I don't know how to do this in webmail. Is show all of the places that the email has bounced between. Dang it. I want to know all of the details about show original. Aha, that's it. Okay. So here is I'm gonna share this screen with you in a second. If you've ever looked at the full text of an email, okay, this giant pile of stuff here is an email that was sent to me like during class just now, and all of this is information about the email and about the header and stuff like that. It's encoding information and all of that stuff. What I want to look at is so this part here, delivered to me. This part here is the IP address of our mail server over at Google. This right here is who it was sent from, and there at Westminster.edu, and this is the IP address of where it was sent from. And you can see through the list of received messages here that it went from here, and you got to kind of do this in reverse order, to this machine, to this machine, 10.1.65.1, to this machine, 70.32.51.110, to the central Google Mail server, 10.55.154.136, to my Gmail server, 10.107.30.65. Okay, so what's cool about this is this email was sent at 11:28 a.m., 11:28:52 a.m. Okay, that's when it was sent by him. It bounced through all of these machines and went through all of this authentication and MI spam and stuff like that, and got to my machine at it's Pacific time, so it's off by 3 hours. So 8:28, which is really 11:28.54. So it went through all of this in 2 seconds. Okay, so it's fun to see an email kind of bounce through all this stuff. And sometimes if you're not sure whether an email is legitimate or not, you know how I don't know if you get this, but I get this all the time from people whose computers have been hacked, and you get these weird emails from them saying "Hey" and then a bizarre link. And what's happening is their hacked computer is sending it automatically. One way to see whether it is legitimately being sent by them or some kind of automatic thing is you can go through the list of who sends what to who and see if it goes along a path from their account to yours, or if it goes through shadyplace.com or someplace like that. There's a lot of cool stuff you can do with this. If the class was longer, I'd make you. This is kind of like a whole day of playing around in the lab in the full semester class, but we don't really have time for that this semester in the summer. But maybe I'll throw it in the final. So the big ideas for today, I think. Let me get back to the writer. Is A, my computer sucks and crashed, and B, domain names are for human readability and go from specific to general. IP addresses are for computer communication and go from general to specific. So that's kind of the big idea I want you to get through today. Hopefully seeing that will help you understand web addresses you see and these weird numbers you see when you're out on the internet. Hopefully it'll help you not get phished as easily. Not that you should ever give your password to anybody under any circumstances anyway, but you know, then this is kind of why. And hopefully it'll help you do the web stuff a little bit better. So any questions on this? Any questions on the homework? Any questions on the web? IP addresses, domain names? Yay. Going once. Going twice. Alrighty. Next week I'll show you a little bit about how programming works, and I'll show you a cute little programming language called Scratch where you can move a little cat around the screen. Do work on the web, homework in lab. Give yourself time to do it. It's a lot of pages and a lot of new things to learn. It's not necessarily hard, but it is fiddly, and you want to give yourself time to manage the fiddly. And send me questions if you're stuck. All right? I will see you guys next week. See ya.